All right, we're going to do 3 examples today, all that use the power rule, plus we'll be using the rules of constant multiple rule and the adding and subtracting rules. So let's start off with a one-term problem. Notice in this problem, y equals 1 over 5 times the 5th root of x. And we always need for our problems to be in the form a times x to the b power, so we can use this rule. So the first thing we'll do is we're going to write that as 1/5 times 1 over x to the 1/5 power, because the 5th root is the 1/5 power. And then we're going to change that to 1/5 times x to the negative 1/5 power, ax to the b. So that's algebra. Now we're going to find the derivative using the constant multiple rule and the power rule. The constant multiple rule says write down the constant in front. Then we're taking the derivative using the power rule, which says write the power down. Then write down your variable and subtract 1 from the power. There we go. So let's see, we're going to have negative 1/25 x to the negative 6/5. Now we always want to write our answers with positive exponents. So notice that would be negative 1 over 25 x to the 6/5 power. And if we wanted to write this with radicals, you might see this written this way. Negative 1 over 25 times the 5th root of x to the 6th power. I would accept either this or this as correct answers. All right, now we're going to move on to the second example, letter B. I'm going to slide this up a little bit. We can come back down if we need to. I will recopy it. F of x equals x times x squared plus 1. Notice we have rules for adding, subtracting, and multiplying by a constant. However, this x is a variable in front and not a constant. So we must multiply first if we're wanting to use that power rule. So f of x equals x cubed plus x. Now we have this as a sum or difference of terms that are ax to the b power. Ax to the b power. In fact, we can write this as x to the 1 if we like. And so now the derivative is 3x squared plus, and we could think of this as 1x to the 0. And remember, x to the 0 is 1, so 3x squared plus 1 is our solution using our power and sum and difference rule. Let's slide that up so you can see it. There we go. All right, now we have one more example, and it was f of x equals 2x cubed minus 4x squared plus 3 all over x squared. And again, we've got a quotient, just like this one is a product, and we had to multiply this out first. In this one, we must divide first. We will have rules later on for products and quotients, but for right now we want to avoid that. And in fact, anytime we have a monomial, which simply means one term, in the bottom, we're going to want to divide first. It always will be easier to do that. So if we divide first, that means 2x cubed over x squared minus 4x squared over x squared plus 3 over x squared. Notice I've divided each and every term by x squared. Now let's simplify. That will be 2x minus 4 plus 3x to the negative 2. And now what we want to do is find our derivative. We've done our division. So we'll use the power rule. All right, the derivative of 2x is simply 2, just like the derivative of x was 1. The derivative of a constant by itself is 0. Now we have a constant in front. We multiply by the derivative of x to the negative 2 using the power rule. Negative 2x to the negative 3. Bring the power down in front, subtract 1 from the power. Simplifying, we get 2 minus 6x to the negative 3. And we always want to write with positive exponents. So that's 2 minus 6 over x cubed. You might see this written 2x cubed minus 6 over x cubed. All they've done is have a common denominator to combine those two terms. I would accept either one of these solutions.